The warning is stark and the setting is common. A single breath of dust in a poorly ventilated attic could lead to a lethal infection. Epidemiologists are focusing on the extreme risks associated with hantavirus, a pathogen carried by rodents that remains a significant threat to public health across the globe. This concern is grounded in the virus's primary mode of transmission, the aerosolization of viral particles. When rodent urine, droppings, or nesting materials are disturbed, such as during the cleaning of a long-neglected storage space or attic, the virus becomes airborne. This lethal dust is then inhaled by unsuspecting individuals, potentially triggering hantavirus pulmonary syndrome or HPS. While the risk of infection in the general population remains statistically low, the high mortality rate, which often reaches between 35 and 40%, makes every exposure a matter of extreme clinical concern. In the current 2026 landscape, surveillance efforts have been heightened following reports of clusters in both terrestrial and maritime environments, reminding public health officials that this is not merely a rural or wilderness issue. +3 hantaviruses are a family of viruses spread mainly by rodents. Each hantavirus strain is typically linked to a specific rodent host. In North America, the primary culprit is the deer mouse, though the white-footed mouse, rice rat, and cotton rat are also known carriers. In South America, the Andes virus, a particularly concerning strain, is carried by the long-tailed pygmy rice rat. These rodents shed the virus in their excreta throughout their lives without appearing ill themselves. The framing of this public health threat centers on the resilience of the virus in the environment. Studies indicate that hantaviruses can remain infectious in the environment for several days, depending on temperature and humidity levels. The greatest danger occurs in enclosed, low-traffic areas like attics, basements, and sheds, where viral concentrations can build up over time. As spring cleaning and renovation projects increase, so does the frequency of these high-risk exposures. This is the context in which epidemiologists are issuing their most recent warnings, stressing that the window between a seemingly harmless breath of dust and a life-threatening medical emergency is dangerously narrow. The clinical and logistical response to hantavirus has seen a surge in activity during the first half of 2026. International health agencies, including the World Health Organization and the Centers for Disease Control and Prevention, have recently coordinated on investigations into clusters that highlight the evolving nature of hantavirus surveillance. Of particular note is the May 2026 reporting of a cluster involving the Andes virus. Unlike most other hantaviruses, the Andes strain has documented, though rare, person-to-person transmission capabilities. This has led the ECDC and other bodies to implement rigorous contact tracing protocols, including a recommended 42-day monitoring period for those exposed. For individuals who have inhaled contaminated dust, the initial symptoms are often deceptive, mimicking common respiratory or gastrointestinal illnesses. The prodromal phase typically includes fever, severe muscle aches, particularly in the large muscle groups like the thighs and back, and significant fatigue. In many documented cases, patients also report dizziness, chills, and abdominal pain. +2 as the disease progresses, usually within 4 to 10 days after the initial phase, the respiratory stage begins. This is characterized by the sudden onset of shortness of breath and a rapid accumulation of fluid in the lungs. In the lab, pathologists are using advanced diagnostic tools to identify the virus as early as possible. Testing protocols involve a combination of serology to detect IgM and IgG antibodies and molecular testing using reverse transcription polymerase chain reaction, or RT-PCR, to find viral RNA. Because hantavirus is a high-consequence pathogen, laboratories must handle specimens under enhanced biosafety Level 2 or Level 3 conditions to prevent accidental exposure to lab personnel. Current reporting from clinical settings emphasizes that while there is no specific antiviral treatment or vaccine currently licensed for HPS, early admission to an intensive care unit is the single most important factor in patient survival. Hospitals are increasingly utilizing extracorporeal membrane oxygenation, or ECMO, to support patients whose lungs have become too fluid-filled to function, buying the body time to fight the infection. The contrast between the initial one breath of dust and the intensive, high-tech medical intervention required just days later underscores the severity of the epidemiologist's warnings. Prevention and public guidance remain the most effective tools in the public health arsenal against hantavirus. Because there is no cure, health officials emphasize that the burden of safety lies in avoiding exposure entirely. The primary recommendation for anyone entering a potentially infested area, such as an attic or a crawl space, is to never dry sweep or vacuum. These actions stir up the very dust that carries the virus. Instead, the standard protocol is to thoroughly wet the area with a disinfectant. A mixture of 1 part bleach to 10 parts water is the universally accepted solution. Contaminated materials should be soaked for at least 5 minutes before being wiped up with paper towels and double-bagged for disposal. Public health agencies are also calling for a conceptual reset regarding how we view airborne risks. While many hantaviruses are strictly zoonotic, the 2026 investigations into the Andes virus have prompted a debate over the necessity of universal airborne precautions, such as the use of N95 respirators, in both clinical and cleanup settings. Beyond individual cleanup efforts, long-term prevention involves rigorous rodent control. This includes sealing any holes larger than a quarter-inch in homes, storing food in rodent-proof containers, and keeping outdoor areas clear of debris that could serve as nesting sites. Surveillance programs continue to monitor rodent populations, particularly following weather events like El Niño, which can lead to a surge in rodent numbers and a subsequent spike in human cases. Despite decades of study, much remains unknown about why certain individuals are more susceptible to the most lethal forms of the disease. While the science is clear on how the virus travels from a mouse to a human lung, the complexity of the immune system's overreaction, often described as a cytokine storm, remains a focus of ongoing research. As we close this report, the message from health officials is one of caution rather than panic. Awareness of the environment and the use of simple protective measures can effectively mitigate the risk of a lethal encounter with the dust in our homes. For more updates on global health surveillance, consider subscribing to this channel. National and international health agencies are currently intensifying surveillance efforts in response to these epidemiologic warnings. The Centers for Disease Control and Prevention and the World Health Organization maintain a standardized reporting system for hantavirus pulmonary syndrome, a condition that remains statistically rare but carries a severe clinical profile. In the laboratory setting, confirming a hantavirus infection involves a multi-tiered approach. Because the virus is typically found in low concentrations in human blood, diagnostic labs rely on enzyme-linked immunosorbent assays, or ELISA, to detect specific IgM antibodies which indicate an acute infection. Additionally, molecular diagnostics using reverse transcription polymerase chain reaction, or RT-PCR, allow technicians to identify the genetic material of the virus directly from patient tissue or blood samples. These labs must operate under strict biosafety protocols, while diagnostic testing of clinical specimens is often performed at biosafety level 2. Any attempt to isolate or grow the virus for research purposes necessitates biosafety level 3 containment due to the high risk of laboratory-acquired infection through aerosolization. The complexity of these tests means that confirmation often lags behind the initial hospital admission, requiring physicians to treat patients based on clinical suspicion and history of exposure. Hospitalization for hantavirus presents significant challenges to critical care teams. Medical documentation indicates that the progression from initial symptoms to respiratory distress is often rapid, occurring in as little as 24 to 48 hours after the onset of the second phase of the illness. Clinicians report that the primary physiological event in hantavirus pulmonary syndrome is a dramatic increase in vascular permeability. This causes the capillaries in the lungs to leak fluid into the alveolar spaces, essentially resulting in a non-cardiogenic pulmonary edema. Because there is no specific antiviral medication or vaccine currently licensed for human use, treatment remains strictly supportive. This involves the use of mechanical ventilation and, in the most severe cases, extracorporeal membrane oxygenation, known as ECMO. ECMO acts as an artificial lung, oxygenating the blood outside the body to allow the patient's own lungs time to recover from the inflammatory surge. Surveillance data shows that early intervention in an intensive care unit is the strongest predictor of survival. Yet many patients do not seek care until they reach the critical respiratory phase because the early symptoms, fever, myalgia, and fatigue, are indistinguishable from more common, less dangerous viral illnesses. The logistics of managing this public health threat extend beyond the hospital walls and into the realm of environmental surveillance. Health departments routinely conduct rodent trapping and sampling programs to determine the prevalence of the virus within local deer mouse and cotton rat populations. These efforts are particularly critical in areas where human development encroaches on rural habitats or where abandoned structures provide ideal nesting grounds. The lethal dust described by epidemiologists refers to the dried residue of rodent urine, droppings, and nesting materials which contains the virus. When this material is disturbed, the viral particles are lofted into the air as microscopic droplets or dust motes. Scientific studies have shown that the physical properties of the virus allow it to remain stable and infectious in these dry conditions for varying periods, depending on environmental factors like UV exposure and humidity. Consequently, the tracking of weather patterns, such as heavy rainfall followed by drought, is a key component of public health forecasting, as these cycles can lead to a surge in rodent populations and a subsequent increase in the viral load present in domestic environments like attics, barns, and crawl spaces. Authorities emphasize that, while the threat is significant, it is also predictable, allowing for targeted intervention and public awareness campaigns in high-risk zones. Prevention serves as the final and most critical layer of defense against a pathogen that lacks a specific cure or vaccine. Because hantavirus is primarily contracted through the inhalation of aerosolized particles, public health guidance focuses heavily on the methodology of cleaning and habitat modification. Epidemiologists stress that the most dangerous action an individual can take in a potentially infested area is dry cleaning. Sweeping with a broom or using a standard vacuum cleaner can lift viral particles into the breathing zone, creating the very lethal dust that leads to infection. The standard protocol for safely decontaminating a space begins with vigorous ventilation. Officials recommend opening doors and windows for at least 30 minutes before entering a long-closed space to allow for fresh air exchange. When cleaning begins, the use of a disinfectant is mandatory. A solution of 1 part household bleach to 9 or 10 parts water is the globally recognized standard for neutralizing hantaviruses. This solution must be sprayed directly onto rodent droppings, nests, or contaminated surfaces until they are thoroughly soaked. A critical detail in this process is the contact time. The bleach solution should remain on the material for at least 5 minutes before it is wiped up. This ensures the chemical has sufficient time to break down the viral envelope, rendering the pathogen inactive. All materials used in the cleanup, including paper towels and gloves, should be double-bagged and disposed of according to local biowaste or household hazardous waste regulations, beyond immediate cleanup. Long-term surveillance and exclusion strategies are the only reliable ways to reduce regional risk. Public health departments engage in integrated pest management, which emphasizes the physical exclusion of rodents from human dwellings. This includes sealing any gaps or holes in the structure that are larger than 1/4 of an inch, rarely the width of a pencil. Using materials that rodents cannot easily chew through, such as heavy-gauge hardware cloth, metal flashing, or steel wool mixed with caulking compound. From a surveillance standpoint, officials monitor environmental variables that influence rodent population explosions, such as unusually heavy rainfall followed by mild winters, which increase the availability of seeds and insects. These ecological shifts are often early warning signs of an upcoming hantavirus season. However, despite these robust prevention frameworks, significant limits to our knowledge remain. Virologists continue to investigate why some patients experience a mild course of illness, while others succumb to rapid respiratory failure. Current research focuses on the host's immune response, specifically the cytokine storm, where the body's own defenses cause the massive capillary leakage characteristic of the syndrome. There is also the ongoing challenge of diagnostic speed, since early symptoms are non-specific. Many cases are not identified until the patient is already in critical condition. The ethical responsibility of public health reporting in this context is to balance the severity of the lethal dust warning with practical, actionable calm. While the mortality rate is high, the absolute number of cases remains low, and the risk is almost entirely preventable through informed behaviour. Experts maintain that while we cannot eliminate hantaviruses from the natural environment, nor should we, given the ecological role of the rodent hosts, we can effectively eliminate the bridge of transmission between the animal reservoir and the human lung. The goal of this reporting is not to instill a fear of the outdoors or domestic storage spaces, but to ensure that when a citizen reaches for a broom in a dusty attic, they possess the scientific literacy to stop, ventilate, and disinfect. This proactive approach transforms a high-risk encounter into a manageable household task. By adhering to established biosafety protocols and supporting ongoing environmental surveillance, the public can mitigate the threat of this hidden pathogen. For continued coverage of global public health developments and emerging viral threats, consider subscribing to this channel.